So I'm Navdeep Punia from University of Bristol. I'll give a brief overview of what network function virtualization actually is. We have talked a lot about NFV during our presentations, and I will just quickly go through it. So what exactly are the network functions? Network function is any entity within the network infrastructure which is having some interfaces and has a behavior to process network traffic. Typically, a layer 3 router can be a network function which is processing packets moving from one subnet to the other. Other than that, there can be firewall which is blocking a certain network traffic or allowing the other traffics to move through. Another type of network function can be a load balancer where packets are coming in and load balancer is pushing the packets to various different endpoints, right? Traditionally, the network functions are based on the hardware, so which are called middle boxes. So middle boxes are basically purpose-built hardware of network functions, and which are created for a to solve a specific function within a service provider. The main drawback of such kind of design is they are very complex and they take a long to deploy and have a long design integrate life cycle. Other than that, they introduce a huge capital and operational expenditure. Moreover, they also need a dedicated space and power in data centers. So these are the main drawbacks of these middle boxes. How NFV solve these solve this problem is by introducing these middle boxes and converting them into a software-based network functions. Basically, essentially, it takes out the software by disaggregating the hardware and the software and deploy them on demand on commodity servers. They can run as a virtual machine or containers, as we have seen in previous presentations. There are a lot of NFV benefits, as some of them was already discussed by Marius in his presentation. So I will quickly go through a few of them. As we have seen in my previous slide, there is a space and cost constraint which can be tackled very well by NFV. Other than that, scalability. So on-demand deployment and rapid scaling up and down of VNFs can be done, which allows better resource utilization and network traffic based on the network traffic behavior. However, further on, it can be automated. The deployments of VNFs can be automated and allows further research into machine learning so that we can bring in the machine learning techniques into NFV deployments placement to optimize the resource utilization as well. Other than that, of course, we reduce these time to market because bringing in a software and employing all the techniques of DevOps like CI/CD techniques, which we will discuss later on in one of the presentations, and all these kind of techniques can reduce the time to market these VNFs. NFV is enabled by the cloud computing, which means we have on-demand compute resource availability, depending on which we can deploy the network functions faster and more efficiently. The virtualization, we can deploy network functions earlier we were using virtual machines, but nowadays we are moving on to the container-based network functions as well, which of course allows the flexible deployment. The most important thing is the multi-tenancy, where the multiple users can use the same infrastructure to deploy and operate their network functions. The SDN part was touched in the previous presentations, and the SDN and NFV works side by side. So SDN allows dynamic provisioning of network to interconnect multiple VNFs, even not only VNFs, even physical network functions within virtual network functions. So the concept of service function chaining comes into picture. So in service function chaining, we can assume there are multiple VNFs which are running in various different data centers or a single data center. It can be, it is the user's choice of deployment. So in order to chain the network functions, we use a VNF forwarding graphs, which is basically an ordered sequence of VNF starting from source to destination. How the packets will be moving, we define using service function chain. So it allows basically the steering of traffic through the VNFs. Suppose in an organization there are two teams which are using one team wants their packets or the traffic coming to them to move through three different network functions like firewall, deep packet inspector, and a proxy server. while the other team just needs a firewall and a proxy server. So the instances are same, deployed on the same infrastructure, even but can be used by multiple different teams in a different way by the concept of network slicing. So I will keep it short, and this is basically the overview of network function virtualization and how we are using the SDN concepts in with that. Thank you very much.
Okay, thank you, Saeed. That was very quick. Thank you so much. I will leave your questions about NFV for later on, so we don't delay too much.